folks, so here we are is the homework from the last day. This was question 1, this was the higher level question, and this was the ordinary level question. So I'm going to check on Teams that you have them done, but I want you to go through your answers and see, do you have the points? So in the very first question, it asked you for the process of inhalation, specifically talking about volume and pressure. So these underlined points up here are compulsory. If they're not in your answer, then you don't get these 2 by 3 marks. And then for anything else, you will get, again, 2 by 3 marks. So using ICC-DI-DI as your way in, we have our diaphragm contracts, we have the diaphragm moves down, we have the intercostal muscles contract, so straight away, and we have air in, so straight away you have hit the 2 by 3 marking points very easily. In the second question, it wanted the process of inhalation, so this has, if we just look at ICC-DI-DI, we have your intercostal muscles contract, diaphragm contracts, diaphragm moves down, volume increases, pressure drops. So C, C, D, I, and D. And the other things that we had said when we went through it is the fact that your brain sends a message to the muscles and that the rib cage moves up and out. They were the extra points. But you would have 1, 2, 3, 4, 5 of the marking points going for just remembering this process. So in the ordinary level question, it was the gas for respiration that's required, which was oxygen. It asked you about the 2 sets of muscles that contract, which was your diaphragm and your intercostal, and then it asked you to explain the process of inhalation. So again, even in ordinary level, they are still looking for intercostal muscles contract, diaphragm contracts or moves down, lung volume increases, pressure decreases, air moves in. So using the ICC-DI-DI, you would easily get the 4 marking points that are available, and the only one that we didn't include in our ICC-DI-DI is the rib cage moving up and out. So we've said that's something that you're either going to remember or you are not. So as I say, I will have checked this on Zoom. Now today we're going to talk about breathing rate. This is specifically higher level content. And you need to be aware that they're obviously going to ask this on a higher level paper. So if you have a little chat to yourself now and put your fingers on your neck, you will feel vibrating in there where you are speaking. And this is your larynx, your voice box. And what it essentially is a whole little thin sheets of muscle. And when the air passes through and how we move our tongue and our mouth and even having teeth, all together they help us make sounds. So this, we're on roughly page 145 of our notes book. So you know you're a page or a little bit behind or in front of me. Now, we are going to do the brain coming up shortly in one of our next topics, and you will be able to label all of these parts and even draw it, but for the moment I'm going to refer you to this part here. Now I call this the bird with the big belly, and roughly here, when we draw it, these are his feet, and his feet are a thing called medulla oblongata. So it is a really cool name and you need to remember it, and this is responsible for how we control our rate of breathing. So if you're underwater and having to hold your breath, here's what's going to happen.
Here's a different example. Take breathing. It's extremely complex. And we actually have chemical receptors in our brain, in the medulla oblongata, that measures the amount of carbon dioxide or the acidity of our blood. And if there's too much carbon dioxide in our blood, it sends a signal down to your spinal cord and down to your lungs. And the signal tells your skeletal muscles, the diaphragm, to contract and relax faster. And the diaphragm is attached to your lungs. And the faster those muscles contract and relax, it's actually the faster you're going to breathe. And therefore, you can able to get rid of all that carbon dioxide and have the potential to bring in more oxygen to do cellular respiration.
Okay, so our medulla oblongata, what do we need to know? So we breathe automatically. It is what's called an involuntary reflex action. So involuntary means that it is not under our conscious control. So our brain is doing this. We can't change the outcome. Our brain is going to make us breathe no matter what. So that's what it means when it says unconscious, not under conscious control. So it's involuntary. We don't get a choice in how to do it. And as we've said, it's now this place, medulla oblongata. So you kind of see the bird, and it's the bird's feet. Now this rate of breathing is always going to be adjusted automatically for us because of homeostasis. So the ability to maintain a constant internal body temperature. We don't get a choice. So you can try this now. You can hold your breath, and eventually you are going to have to breathe in whether you like it or not. So in terms of how is this control of breathing an example of homeostasis? Well, we've just said that the rate is continually adjusted to meet your body's needs. So what is the detail that you need? Well, we have receptors in our medulla, and they're sensitive to changes in the carbon dioxide concentration of your blood. And if you have a very high carbon dioxide concentration, you make your blood more acidic. So if you're exercising or if you're holding your breath, the carbon dioxide levels in your blood decrease the pH of your blood, and they make it acidic. And those receptors now pick that up. And once they do, your medulla will send impulses to the diaphragm and your intercostal muscles, and it makes them both contract. So we've done last lesson the ICC DI, and we know that if your intercostal muscles contract and your diaphragm contracts, your diaphragm is going to move down, your ribs move up and out, and we get an increase in lung volume and a decrease in lung pressure, and air moves in. So if this happens to you, if you're underwater and you're holding your breath, eventually your medulla will make your diaphragm and your intercostal muscles contract. There is no getting around it. So most breathing is unconsciously set. We can obviously voluntarily change the rate at which we breathe. So if you sit there now, you can make yourself hyperventilate, you can make yourself breathe faster, but what you can't do is you can't make yourself not breathe. So your brain just won't let you do it. If you ever watched freedivers, so these are people that go ridiculous depths. I think the record is over 100 meters. I stand to be corrected on that, but these are people that they voluntarily change the rate at which they breathe before they go into the water, so they get as much oxygen as they can into their lungs. They're obviously ridiculously fit, and they've trained for this, and they can go down 100 meters without any tanks, and then they can come back up, and they'll do it on one breath, because they have trained their medulla oblongata essentially to not make their diaphragm and their intercostal muscles contract. So when my kids are holding their breath underwater, I always tell them you need to actually be exhaling a little bit to getting rid of some of that carbon dioxide in your blood, and that will allow you to actually stay underwater longer. Now, the last little bit that we have to do on this today is just, if we were in school, we'd have this bell jar model. It's kind of like the bottle model we had at the beginning, and it's just, again, what are the points that resemble the parts of our lungs. So we now know this represents our trachea. This is representing the bronchus. These are our lungs. The bell jar here is our rib cage, and the diaphragm down here is our diaphragm. Apologies, can't spell today. And what we know now, if we pull down this tag, our lung volume will increase, the pressure decreases, and air moves in, so they'll inflate. And then if we were to push this diaphragm up, it is the same as relaxation, so the lung volume decreases, the pressure increases, and the air will move out. So with all of the systems, we mostly have to have some disorders that go with them. And the one that I'm going to pick is asthma. So you may or may not have asthma. And what is it? It is essentially when your bronchioles or your bronchus gets aggravated and inflamed and gets smaller in size, so it's going to contract. We could do bronchitis, we could do emphysema. These are both lung diseases. If you have somebody that knows them and you have a connection to them, then absolutely please use them. But I'm going to stick with asthma as our breathing disorder of choice. So here we go. You have to have, what are the symptoms of asthma? So if you have asthma, wheezing is obviously the one that most people would associate with it. Breathlessness would be one. Tightness in your chest. And it's then what are the things that cause this for us. So it can be pollen in the air, so springtime and summer are not fun for some asthmatics. It can be animal dander, so this is little secretions they have on animal fur, so some people can be allergic to cats. For some asthmatics, smoke can cause them problems, dust mites can cause problems, and certain chemicals. So you need to pick a couple of symptoms. I personally would go with these ones because they're the ones that we probably most commonly associate it with, and these would be the most common of causes. For some individuals, winter can be really tough in terms of exercising because the cold air can actually cause asthma attacks. So then that's why we say you breathe in through your nose, so that at least warms the air before it gets to your lungs. And they would also use, or friends of mine that would be very badly asthmatic and would do winter sport, they will actually cover their noses and their mouths as they're warming up, just to give their lungs a chance to get used to the conditions and not shock them with cold air straight away. As well as having causes, you have to have prevention and treatment for it. At higher level, you have to be very specific. The word inhaler alone at higher level will not get you any marks, so please don't use it. So the drug treatments that people will use, and they're again the colors of your inhalers, they're called bronchodilators. So dilation means to increase in size, so they make your bronchioles get bigger, or steroids. But please do not use the word inhaler. One thing that is also recommended for asthmatics is that you remove the triggers. So my eldest sister never had asthma in her life. When she got married, she brought all of her books with her. It was a slightly damp house. Became a really, really bad asthmatic because of all of that book dust and the dampness of that house. So by removing all the triggers, changed all the carpets, changed heating, and it got better for her. But again, we just go back to reiterate, inhaler is not the answer that you want to give in terms of prevention or treatment of asthma. So I am on Zoom now for the rest of this. We have pretty much finished this topic with the exception of the mandatory practical, and then we will be doing a little bit of playing, and before February half term we will have our end of topic on the respiratory system. Okay, talk soon.